Okay, so today let's try to do really small precedence like a parser for arithmetic operations in Python. And that's mainly because I already did it for the cool compiler. And I mean, I had a lot of struggles with it, so I wanted to show how to actually do it first try by making it like in a simpler language like in Python. Because let's not I mean, I will also show you how I did it in C at the end, but first let's make it really easy with Python. And basically the idea is that whenever you have a, so let's say for example in cool we have like this precedence order, right, for operators. I mean, these are the ones that are more interesting. The other ones don't mind about it. Just pluses and multiplications. So the idea is that well, you want to parse just pluses and minuses, and only after you are done with pluses and minuses, you go up the precedence um, scale, let's say, to the next operators. And yeah, basically, how I was doing it wrong was that I was trying to parse a single term on the left side. Like how I was trying to do it was like an expression was either a single term, let's say, or a term plus another expression, right? Like this is how I was trying to do it. And then term, I was like, well, the term is either a single factor or a factor multiplied with another expression. And yeah, I mean the factor is just a single number. So I don't know how to, let's say int, right? Either an int or an expression with parentheses. Let's say for example. So yeah, like the thing is that this works, it's fine, but when you look at the parse tree, let's say we had 1 plus 2 multiplied by 3 and then divided by something that's like 4. The issue with this was that the parse tree, like for the beginning it was fine, like 1, and then we had the 1, and here we had the multiply, then a 1, I mean the 2, the division, and then 3 and 4. And the problem with this is that it's I think it's called right associative because it starts from this side, from the right, from, I guess it goes to the right or something like that. And that's not really good because it means that when we solve the parser we go here first. So we actually solve it from right to left, and we want to solve it from left to right. So this grammar wasn't really good. So how it should actually look like is, and I just found it like 2 minutes ago, this one. I just searched on, if I searched for this, like, when I first did it, I might have gotten it, but not sure, because it took me a lot of tries to figure out that you have to do it like this instead. So basically the other idea, if we look at this one, is well, an expression, yeah, as before, is like a single term, or here it says a single term or a term and then plus term, and this is like any number of times, but we already have t there, so let's do something else. Let's say t and then plus another term any number of times, right? Like if you say it like that, and then the term is just a factor, and then it's multiplied with any number of factors. And the factor was, as before, an int or a expression with parentheses. And yeah, if you get our example from before, and let's make it actually not work with the old way. So let's do division first. So yeah, when you solve this, you have to do first division and then multiply. Like when the YouTube quiz with people saying 2 times. Anyway, and the parse tree now is something like first you get a plus, and you have to keep going. Basically, you have to keep going until you get all the pluses. So we only have one, so that's everything. Then for the factor, we have to do the first factor, and then we find the division. So we are gonna build something like this, 4, and then here we have empty. We don't have anything. Let's put a question mark. Then we go even further and we find the multiply. So we have to shift this entire tree to the left and put the multiply higher up. Right, something like that. And we also found the 2 that should come here. So yeah, I mean, before putting the x, we were already read the 2, so we put a 2, but now we find the multiply, so we put it like this, higher up. And then the last one is a 5, and it comes here. And this multiply is basically connected to there. So yeah, the idea is we have to, each time we find another multiply or divide or minus or plus, we have to shift the entire tree to the left one step. Basically, that was the main idea. And yeah, this was actually the right grammar to make it. Let me see it first. Make it left associative, whatever that means, basically. And yeah, when you have a lot of operators like this, what you actually have to do is, just so if we, let's say, add the, I don't know, is void thing, then here we have f1 is gonna be is void of f or simple f, basically, right? It's like one extra step between them. So, and then if you want to add this thing, you add it on the top, or like before this one, basically. So that's the main idea here, and yeah, it took me like a whole lot to get it. So yeah, I mean, let's do it in a test.py file, and let's make things like really easy. So we're gonna get tokens split input by space, or how do you do it? Is it input.split, right? So we get all the tokens, and yeah, let's do class token, and this is gonna be init. Well, what we don't really need a wrapper though. If name is equal to main, we read this thing. Let's say this is tip, or I mean type, but without the e. and yeah, token int, token plus, token minus. Let's just make things really easy. Token mul, token div, left parenthesis and right parenthesis. Okay, so can we do a static method def from str and yeah, basically just something really stupidly simple. So we build the tokens, and here we can actually just do something like token from str. Let's print the tokens. So Python test.py 1 plus 2 multiplied by 3 and divided by 4, and we just so wrapper was actually something useful. Let me just have an echo in here because it's gonna be annoying to write that every time. This. So yeah, we get some stuff. Let's also do parentheses just to make things more difficult. Wait, we need spaces between everything. Yeah, anyway. So we don't do a lexer, we just get the tokens because we don't really care about the lexer. Okay, so let's have now a class for st node. Init, we're gonna get self. We will need a value. Okay, and we are also gonna have left hand side, right hand side. Is that correct to have? I think so. I mean, only for parentheses. We don't really have well, we can also keep self dot token equals token, and because we are going to build it from a token. So yeah, something like this, and it's going to have a reference to the other nodes. So basically, if we have now a function parse expr, in this function we get tokens. Well, yeah, it's easier to have a class parser self tokens equals tokens self dot index equals 0 or something. Okay, parse expression is gonna do self, and yeah, basically this thing, what we have to do, let's have a little small function get next token, which just now gives us the token. I mean, yeah, whatever. So parse expression is basically we need a term, so term equals self parse term, right? Then we need a while loop, but I would have said that token equals self get next token, and while token dot type is equal to token plus or token type is equal to token minus. Basically this is this step of doing, well, we found a single term and now we found a plus or a minus, and since we have a star, it's while we do that. So yeah, then we have to advance. I mean, let's also do a function advance, just to advance, to make things look okay. We advance, then we create a new st node for the plus. Basically, we set the left hand side of this term as, or of this node as term, right? So that's like we put here the 4 for the division. Okay, then for the right hand side we need to parse another term. So how we started to parse here and found the 2, right? We initialize the 2, and afterwards we need to take the term and yeah, basically the next time we are gonna find another plus or a minus, and in this case, I mean, I know it's multiply and division, but the next time we are gonna find the next multiply here. Now this is the actual term, it's no longer 4, right? So when we put the left hand side of x, it's gonna be this entire thing. So maybe a better name for this one is root. This is the root node. And here when we create a new node, we set the left hand side of this node as the root and the right hand side as a term that we parse, and then we set the root to be this node, so we shift everything onto the left hand side of the root in some way. And yeah, we need the next token, and sure, fair enough, we return the root node. Okay, now let's do parse term, which should be exactly the same, but for token type we're gonna have multiply and divide, so that's the only difference. Then let's do the parse factor, and yeah, I mean, parse factor is also pretty simple. We did it also in cool. So if we find an int, we just do token type int, and here if we find parentheses, we just have to parse the expression from inside. So like if you have opening, then something, and then closing parentheses, you skip this one, then you parse this as an e, and then you skip this last parenthesis. So that's just that, and I mean, invalid syntax, whatever. So we have the tokens. Let's have a print, or if we do a wrapper here, would that work? So parser print st, let's say. Oh, I wanted this thing. Interesting. Well, yeah, because token can be basically end. So on line 70, well, more like line 82. Obviously, we are gonna do the classic print debugging just to see what happens. So first we have a plus between this int and the 3, which I mean, yeah, let's put something else here just to, yeah, so it goes in the parentheses, which is interesting. So I mean, as I said, the first, when we do parse expression, I'm guessing that the first term should be the 1, like int 1, right? It got it. Then it found a plus, right? We have to advance on the 2 basically, and then we do another parse term, for this one. What I would expect to see is the division first though. So here for parse factor, if we print the root, we should see 2. Like, well, I didn't delete it from just one small thing. So why do we see 1? Oh, because parse term gives us the 1. Yeah. But then we see the 2, the 7, and the 3. So the 2 is fine, I guess. But yeah, like here, I would expect to find the multiplication after the 2, and then this node should be a multiplication between the 2 and this plus. Right, like that's good. And then see, we get the division like this between the multiplication and the 5. So that's actually good. And here when we return print root, what? Well, I guess at some point it's gonna get a null. So let's do something like here. If token is none, then we break. Right, like in this stuff. And yeah, whatever. That's not gonna have an issue. Okay, so we have a plus, but let's print it in a better format. So let's have something like print st. Let's go here, def show self, and let's do depth. It's gonna be like the ident. So print, and let's increase the depth by something more. And yeah, like let's see how this looks like. st.show. st.show. Okay, yeah, it looks better. So here, Not sure why. Oh, it shows none because we already printed stuff, I think. Yeah, we do print here, so we don't need to do that. Okay. So yeah, basically, as I said, we get the plus first between this thing and then the division. And if when we solve the AST, we start from the most inner thing. So we do this plus first, then we do the multiplication between these things, and then the division. So we can try to do also the solve. So def evaluate of self, and basically, yeah, if it's, I mean, should be pretty simple. If it's an int, it's just the int. If it's plus, then we add together the left hand side and right hand side. For minus, we do the same thing. And is the evaluate. So yeah, we have so this thing is 10 divided by 5. It should be, well, I said let's calculate like from this side, right? So it's gonna be 10 times 2 is gonna be 20 divided by 5 is gonna be 4 plus 1 is gonna be 5. So this is actually okay, right? So yeah, basically that was the idea. So now since we have this stuff, let's go and see how I well, not really in main but in parser.h. And yeah, prepare yourself because that's it's really ugly how I did. So the expression node, you saw that we have quite a lot more stuff in this thing, and I mean actually it's this one, so we need to represent each one. And here Rust would have been better because you can have enum with structure inside, but here even if we have this enum, like it's just integers. So I use the union to like have a struct for a sign, a structure for function calls. Yeah, I mean I know I totally agree. But I mean it is what it is. I needed to get this going. So I mean one way to do it. I don't know how a better way would look like. 50 lines of code inside of this union, but it's fine. It does the job. That's what's more important, to be honest. And yeah, basically like building nodes is pretty simple. Like the if node is pretty easy to build. You just have to find the keywords, and then if you look at the if, you can see that it's sort of like a keyword then an expression. So if you look at this, it's the if keyword, then we have build expression, right? As we did for our stuff in Python. So it's pretty much the same thing, but with more stuff. So like all the ifs or the whiles, the parenthesized expressions, all of them come inside of this factor. So this factor contains all of the things, right? Like let's see, like all of the ifs, the whiles, blocks, I think it was, let statements, cases, new types, like everything that's not here, basically. So yeah, after that, let's go to build expression. Oh, jump of 500 lines of code. I know. So for expression, it's something like we have to, yeah, like this was a bit weird to me, but the lowest precedence is a sign. So if you have something like, let's do another drawing. If you have something like a is equal to 1 plus 2, the parse tree should be like the sign, then you have the a, and then you have plus, and then 1 and 2. So like um, when you have in some expression, the sign will always be the root, let's say, it will always be the root, and after you go one step inside, you are gonna find just these these operators. You're not gonna find another sign unless it's parentheses. But the main idea is that the lower you go in the parse tree, you're gonna find less and less operators. So that's one trick to keep in mind, basically. Like if you found all the multiplications, you can only find these operators. Or I mean a parenthesized expression, but that's like, anyway, it's parenthesized, doesn't matter. But this is the trick, basically. If you find the last multiply, well, you are only gonna find these void, negations, and function calls. So pretty much the idea. So yeah, we build the expression for a sign, and yeah, we have two options then. If we found an sign, then we have to parse this expression as an expression, and we can do that because it's not left recursive. We already consumed some of the input, so it's not gonna do a while true. And if we didn't find an assign, then we go up the precedence scale. We go to the next token, to not. Right, so then if we look at not, this one will look for the not token, and then we have to, here we no longer do just expression, because as I said, we are no longer gonna find a sign. Right? We are no longer gonna find a sign. So we have to go again higher on the precedence scale. So we now have to build expression for compare. Right, so we go up, and inside of compare we are gonna have like almost the same thing, but we need to have first, as we did for terms, we have to parse an add expression, and here it's just that it was easier to use the these as the names, like the operators as the names, right? So this is compare terms or expressions, this is add expressions, multiply expressions, and so on. So we read a single add expression which doesn't contain any operators like this, like equal and stuff. So it's just addition, multiplication, and so on, whatever. And then if we read while we read this type of tokens, we continue to read other add expressions, right? And as we did in the Python version, always shift the tree to the left hand side. So yeah, we read an add, and if you look at this, it should be really similar to the one that we did in test.py. So let's look at which one, this one, parse expression. So if we look at this one, see, we read inside of the root, we put the term like this, right? Then we whatever parse the current token, and if it's plus or minus like this, right, we have to basically here we just initialize stuff. So in Python it's much easier to initialize. Where we don't even need to initialize actually. But yeah, we advance. So I mean the advance is like putting this after this thing. So yeah, it's just initialization. Then we advance, and then we read another term inside of right hand side. So here we read it inside of right hand side. Then we switch the root and the node with this, and then we just take the next token. Right. And I mean, yeah, there, I guess this thing is done much easily because we don't set the token to none or null. We just set the type to not be plus or minus, and it exits. And yeah, at the end, here we don't use returns. We just have the return value as an argument. So that's the entire thing. And yeah, for multiply and divide, it's exactly the same. So yeah, that's all what I wanted to showcase. Okay, and yeah, in fact, here we should. So I skipped a step, as you saw maybe in the checker. I didn't start to work yet on function calls. So I mean we can do that now since we have more time. And yeah, basically we should keep it with the same logic. So instead of going straight to the simple expressions, which is just identifier, int literals, string literals, and so on, we should actually do build expression function call or something like that. Or I guess first one is at, and then it's dot. So yeah, let's see. So here should be actually build expr, let's say at, and we give it this thing, and the other option is to just have the at. Right, so static void build expr at should be parser and expr node expression. Okay, so inside of this one, what we have to do is to parse an expression first, which is gonna be let's say of higher precedence. So it should be the plus one, the dot one, sorry. So we need some stuff like this. Okay, and here we need to call to expression dot, right? Like that's the main idea. And while, do we have a good while? Not really. While token type is equal to at, right? While we read an at, what we have to do is let's just copy paste stuff. It's I don't know. So while we read an at, we have to read also the rest of the stuff, right? Like the rest. So we create a current node. We don't have this binary stuff. We can leave it. And we can say current dot dispatch full, and dispatch full is basically a function call with the expression in front of it and the type and yeah, whatever. So it's an expression full, and we just set the expression like this. Then we have to say what? We need to read the type. So we need to read this type. Yeah, basically we can advance, but let's first ds dynamic reinit. We initialize the arguments. Current dispatch full type dot value equals null, just to initialize it, and method value equals null. So we just initialize the thing. Okay, yeah, perfect. So now we need to get a token after we advance, and if token type is not equal to class name, then it's an error. Basically, we need this. I mean, since we found at, we need this to be required. Okay, then if token, well, it's not really right, it should be equal, and here we just need to initialize our type, and otherwise it's an error. That's okay. We need now to advance again, and here if token type is not dot, then we have an error because dot is required. Then again we need to advance. Then if token type is equal to ident, then we can initialize the method name, otherwise it's an error. Then we need to do the same thing for the list of expressions, or at least similarly. So basically, if token type is not left parentheses, then it's an error. Okay. Then we need to advance once, and here we need to do a while loop. While token type is not equal to right parentheses. Actually, not really. It's more like if token type is not equal to right parentheses, we need to read one argument. And the argument can be basically any expression. So let's think about it a bit. Well, this is actually like a function call. So let's have better a separate function for building a function call. Then, having all of this stuff here. So let's take this and let's go build node fcall. So static void build node function call start parser and expression node expression. So yeah, something like that. and if we just copy paste from here, we can just initialize stuff. So we take the token, have the expression, type is expression. I mean, it could be like dispatch. So then well, this doesn't need the expression. I was just thinking, what if we replace this with this, but doesn't matter. We can do it easily like this. So expression is dispatch, and we have to initialize nothing actually. We just have to do ds dynamically append the arguments. We need to initialize the arguments like this. Right. Then if we don't find an identifier, this is expression, we show an error, then advance, we find left parenthesis, then if we find the closing, let's see, so if we find the closing parenthesis, then we can just return, make it like a guard close, and otherwise it means that we need to read expressions. So let's see, expression node argument, we might have to see if Copilot gets it. So we build the expression, we add it into the arguments, we take the current node, it should be a comma or a right parenthesis, so we check that, we advance off from it, we read another expression, append it, get the current one, which should be comma or right parenthesis. Okay, and at the end we need to advance once. I mean, I made this mistake before, forgot to put the advance. So then we advance once. That's if it's not right parenthesis. So we advance off from the right parenthesis, but I think that should be actually here. Because if it's right parenthesis, then we also have to step over it. Okay, so that's doing build node fcall. Right, build node fcall, and yeah, that stays like that. And here, after we find the dot, we need to say something like node, what is like expression node fcall, build node fcall, we build a node. Okay, something like this. If fcall dot type is equal to expression dispatch, then we should be able to just I mean, it could be worth to say that this thing is just a pointer to dispatch, but at the same time, can't we just do something better? There we initialize the array, Can't we just copy it manually? So this is what? Dynamic array. It's not really a pointer, so it should copy it, I guess. Okay. So here we got the full stuff like this, right? So we don't need to do this build. We set the root node to current, and we take the whatever current token. So we need to do here a build expression dot. That's the last thing. And yeah, I mean this is fine, I think. So let's see, because build expression dot is pretty much the same as, well, I mean it's the same thing, except we no longer have the add. So here we need to call to build expression simple, right? We need to close the loop. Then while token type is not dot, or I mean while it's dot, we need to malloc the stuff. Wait, current dot type is equal to this expression dispatch. It's still full dispatch though. I forgot to put this thing on this one. Yeah, so it's still full dispatch, but we don't have the type, so we don't have this thing. Alright, so the idea is we already consumed all the add symbols. Now that we are in dot, like, as I said, now that we are in dot, the only other expression that can be here is the simple ones or another dot. We no longer gonna find add symbols, we just consumed all of them. So we build the simple expression, we take the current one while it is dot, we build this expression, we advance, we look for the dot, we build an f call node after the dot. Yeah, that's right. We set this one. Oh, and I think here what I'm missing is expression equals root. Yeah, we just have to say that the expression from the argument is the root node that we put here. So that's the last thing basically. And yeah, something like that should do it. And for expression simple, one more thing we don't do is the simple dispatch. We just consider that an ID is just an ID. But if we pick inside of this, so let's do something like this. Struct token next. Let's pick. If next type is left parenthesis, then we need to build an fcall node, and otherwise we are just gonna do our usual identifier. So that's the thing there. And nope. So let's see why it didn't like that. So build expression add. I mean, it's gonna do a build expression dot. right. Build expression dot is gonna build an expression simple. Oh, here it should be. No, it's good. Build expression add and build expression simple. I think here we need to advance ones, but wait, no, we don't need to advance. I mean, we could try to see what happens, because attributing it should work. So let's go to C, let's see attributing it, because this one was working. Ooh, 6 seg. Well, I mean, it's funny because I just saw like a video on using core dumps, but like setting that up versus just using print debugging, so tempting to just do printfs. So let's see what might have gone wrong. So yeah, let's just put here a printf, whatever, just to see something. So wait, what? Like, what were the changes? I guess. Oh, we don't have that, so it might come inside of this one. Yeah, so it goes there. Then I mean, should come here. Whoa, what? Interesting. So this is gonna do expression dot. Oh, it's all because of that 0. Expression dot. Let's see if it gets here. It gets, and then in expression simple, it should be just an int literal. So let's do printf. Let's see the token type. No, like, it's int literal. Man. So it's not fcall or something, it's something inside of either dot. So here we malloc it, it's good. It's not even gonna enter inside of the while loops, right? It's not even gonna enter there. So in here, if we do like, we don't really have that, so root.type, it should be 22. Yeah, that's like 22. It's this one. And if we try to see what we got here, it should be semicolon. Yeah, expected basically. And here we say that expression is equal to root. So I mean, this should work too, right? Yeah, that works. So then for expression at, here we should also find semicolon. Perfect. So this should go down until this thing, where it should also work. And then this doesn't work. So it's something on the referencing expression. Let's see what could be. So neg expression is not allocated maybe, but it is allocated. Oh, wait a second, here it should be just expression. Hopefully that's the only thing where I messed that up, because I changed it now, right? That was one of the changes. So if we look in the diff, yeah, see, I messed it up a bit. Okay, anyway. So if we remake it, that works, and if we just run the checker, this page still doesn't work. It looks like infinite loop. Oopsie doopsie. So let's see what 10 looks like. So first one is a simple function call. I think. Let's see, build expression at, build expression dot. Let's go into this one and do like a printf f call. Let's say at least if building the simple f call works. It doesn't work. So somewhere around here it failed then. Build node f call. Right, so first one should be identifier. Let's printf the token type. So identifier, that's good. Then after identifier we should find, let's also do exit, just so we don't left parentheses. That's good. And here it should be an identifier. So it's gonna get inside. It's gonna build the expression. So let's see here what it's gonna show us. Okay, so it built it. That's good. Then what's the next token? It should be comma. Wait, what? So is that something wrong with the DA append? We didn't allocate the dispatch. Well, yes, we did. Then what's wrong with the argument? Printf %d. Yeah, whatever, let's print that. Let's also print argtype. So it's something wrong with that. Anyway, like if we go to the top of this and say 11 down, it is not good either, right? it's an X. So anyway, it doesn't really matter. I mean, it's an add. I counted wrong. So dispatch args. Fail to initialize the dispatch args for some reason. What? I mean, doesn't init just make everything 0? Yeah, it should. Then what? Dispatch full. Oh, it's not dispatch full. Here it's just dispatch. I messed it up. Okay. Yeah, I messed that up a bit. So let's see again. Now it should be probably like 0. Yeah. So now it should actually just work. Damn it. Okay, so I forgot maybe something. So let's see. Let's do here something like that just to see. So we have the one type identifier. I mean, only the first one is interesting, right? It's like that. So let's see actually in here maybe. Well, it's only one, like, and it was plus, so that's actually it works for the first one. It gives us ident and the fact that it's a plus, so that works, right? But here, if we look at this, we should see for the first one that it's a right parenthesis. So yeah, it is right parenthesis, and we have one item in the arguments. So basically it's gonna exit, right? And if we take a look here at our stuff, we should be able to see that we are on top of the right parenthesis. Okay, so we advance once. I mean, that looks okay to me for this one. So if we do parser current just to see which is the current token, it should be semicolon there. It's an R brace. What? Wait, what? So oh, yeah, because it's inside of the body. So I think, yeah, we need to do that. So I mean, maybe it's okay to be on the right, on the closing brace. So for example, build expression simple. Okay, let's go again and see what the first error was. Expected dot got ident. So here we have fcall. This is going to be called here inside of dot expression. So it's going to look at the current one, is going to be dot. So if we just look at the root, we should see, I don't know where the problem was. Token type plus, what the, wait, what? Root type, let's see. So first it's 21. So from here, if we do 20 on down, it's identifier. It's I guess it's because of, yeah, you know, a few stuff like X here or what. Not really, like, where do we parse expression just here? Man. I mean, it's somewhere like it should be an extra read, like an extra skip, an extra advance in the parser, but I missed it for some reason somewhere. Really don't know. Like, these are called just when you want to build an expression, so like that plus thing from inside of here, like we don't have any other expressions before that. So how is the token plus then? Like, that's strange. Like here the root type should be it says 21, like it's identifier. Well, I guess it is identifier because it's for F first, right? So it's good. Well, no, it's not, because it's identifier. What? Okay, let's check another time. Let's put here. Let's print F, the type of the next, and the type of the token. I think we should see something like ident and left parenthesis, then ident and plus, ident and dot. I mean, it looks good because it's ident and parenthesis, ident and plus, ident and dot, right? And it should be ident and left parenthesis. So maybe it's a mistake somewhere in the, like, this thing looks like it works, right? It gives us a good expression there. If we do something like printf %d expression type, I would say that the first one should be 21. Wait, what? Identifier and left parenthesis. What? Like, how does it? See, here it says f call. I mean, yeah, sure. Because it finds the x, so it's good actually. I mean, actually that's good. It finds the x first and then the function call. So I think function call is actually parsed fine. Then here inside of doing dot, I think like if root dot type is equal to x per dispatch, printf dispatch, maybe we can printf some other stuff like this. But I mean, sometimes Copilot isn't really smart. Like if you make a mistake, it continues with your mistake. Okay, so yeah, f and one argument. So that's good. And what's the next token after this thing? Print. It should be like rbrace, right? Yeah, it's rbrace. Okay, so it's rbrace. Then it's not gonna enter here. It's gonna go to this thing. That's gonna go here. It's not gonna enter there. So that's actually fine. I really don't get where the issue is, though. Expected. Okay, so let's see, line 7. So if we go to 10 dispatch here, so it's line 7, 14. Here it said, okay, so it found this thing, expected dot got identifier. Wait, what? Okay, so in the dot one, there is something wrong. So we read an expression. This expression, let's do printf the type. And let's printf the token type, but let's do it with s because it's nicer. Token type to string. And it's annoying when you get this small little bug. And so yeah, this looks good. This looks good. We get the type 3 and the rbrace. Then we get a 21 and dot. So that's good. Right. Oh, am I stupid? We found a dot. We don't have to check for another dot. We have to do the f call. Yeah, I guess that was one of the issues. So line 11, 25. Expected rbrace got dot. Okay, so now Interestingly enough, so we had an add expression. We had an add expression that looks so we built this expression first, then we found the add. So if we say here print like root type and print f, oh my fucking god, the token type we should see, I mean obviously, but it should be a new. So is 9 new, parser.h, 9 down, it's a new, yeah. So that works first. Then we build a dispatch. We set the expression here on the root. Right. We set the expression on the root. Then these are null. We initialize the thing. We find the class name. We find the function call and put it. Then we look for another add. Let's say actually that so we don't find another add. But what if there is something like a dot expression? So we don't really want to build a function call node. We want more to build the dot thing. Yeah, we want to build a dot call. Oh, that's a bit weird because yeah, we don't want to build just an fcall node. We want to go ahead and try to build the dot expression itself, which might work if we pass in the expression. So for example, we read the class name, right? And now we want to go and parse this thing. But it's like the expression was already parsed in some way, if you know what I mean. Like this root was already parsed. Then even this one doesn't really work. Because, wait. we found a dot, and then what we want to do actually is to recall to this thing. Let's see again how I did it for plus, for example, because that's gonna be the key to this one, or I mean for this one. So I called to this one on the right hand side. So instead of calling directly to well, it doesn't really matter though, because we know it's gonna be a function call node there. So for this one, yeah, I guess it doesn't really matter, because even if we do build expressions simple, we kind of have to assume that it's gonna be an expression. Let me check how the reference looks like. Maybe it's so it's A, like the dispatch dot. So for self, it's application between self and this. This one is implicit dispatch, so it's a bit different when you have implicit. Yeah, so we cannot. Okay, so we assume that it's gonna be build node f call. Then we read this, and then only thing that can happen next is to find another dot, right? Like that's my idea. So maybe this works, like we find another dot and then we do another f call node. That should probably work. But if we have an at, right, we read whatever the class name, we find a dot which is required, and then we call to build node f call. Right, we call to build node f call. But it should be here, so we find it should be a while loop inside of here. Like we should imitate this stuff in some way, because we actually want not to read a node there, we want to read this. So it would be better if instead of calling directly to node f call, here we call to build x push simple, just to make it more obvious that we don't call directly to building nodes. And then here we try to build a node first, or like a dot, right? But here we whatever is the class name, and then here we would have to call to this function, but we cannot really do that because here we try to build an expression and we don't really want to do that. So like maybe another way to do it is to give to this thing as an argument the expression. Right, let's think about it. So we give it the root as an argument. Right, that would make sense, right? Would make sense. And then when we call here, we have to first read the simple expression and then pass it inside of this. I mean, I'm tempted to try it. Like that would be my idea. And then here, instead of doing all of this, we can just directly call to it. So yeah, let's try it. Export node pointer root, we pass it directly. So now we have to take this out. Here we try to parse a simple expression. We don't have to allocate it. And let's see. Let's see. Or maybe we can just say that expression is already no. Yeah, so I was thinking like we put in the root, we put the thing already. And in expression, we don't put anything in some way. But that's just like expression is not even used. So like it's just like giving it just the expression, and instead of root we use the expression. Yeah, I don't know. I don't really know how to do it. Because then it would look a bit weird. Well, the easiest way is to just, copy paste this. It's so ugly. Yeah, let's just try to make it work by giving it the expression node root here. Let's just remove that. So root is gonna come initialized, right? And we are not gonna care about root. Root is gonna be something that we throw away, and the expression is what we care about actually. So here we need a simple expression that we are gonna have here. Simple. Here we pass in simple, and the idea is as follows. Here we parse a simple expression, then we are gonna try to build a dot, right? It comes in, and if it doesn't find a dot, then expression is gonna be simple. So basically root now is gonna be simple from now on. Right, so we go as usual. We go about our day as usual here. And here, instead of doing dot and stuff, what if we, so here we check for dot, we were building the node, what if we call to build export dot, something like this, I think. What if we do this thing? So basically, we know it's a full dispatch. We don't even care about setting these because they are gonna be initialized in, well, not really. So we give it these, advance the parser, get the class name, okay, get the class name, and then here we reset the type though. That's alright. So we give it the current one, and while it finds dots, then it's gonna do expression dispatch, right, like this. But yeah, the only thing that sucks is that we are gonna lose the type. So it's more like we do current is equal to this thing, but is this like gonna change anything? It parsed it, at least. But my question is more like, well, I passed in current here, so current is gonna change. Well, root is current, right? Root. So here we put, we found, wait a second, we found a dot. Okay, so we create another dispatch. No, it's not good. It's a bit strange. So let's say we found an add, right? So current is a dispatch full. We put a class name, and then we go for the dot. And while it finds dot, it assumes that we gave it the expression. That is like the cast. But it's more like we gave it the type, just the type. I mean, we gave it the type and yeah, I don't like this. Let's go back. Okay, so I mean, let's leave it as is because I really don't like that. Because this works, like expression with a dot works. What doesn't work is that here, when we find a dot, we have to actually do a while. I mean, let's do a while here and that's it. So I just keep being annoying. Let's take this. And here instead of, like, if it's not equal to dot, we have a problem. Sure, fair enough. But it's better to then have a while loop. Or let's say it's mandatory to have a dot. Right? And then we have a do while loop where we take the current node. We already have current though. We already have current. We already have current, so it should have another name. But it's like, what should be inside of this? Man, it was such a good idea to somehow be able to reuse this one, but I don't know how to do it exactly. I mean, the idea would be to maybe, because we give it the expression that should stay on expr, and maybe we should also give it the type. But it's more like, not really. I have another idea. Let's see if this other idea is better in a way. So we just read the dispatch, whatever. Here it's an add. So it's dispatch. We read the class name. Then we need a dot, like it's necessary to have a dot. Then we build a node, an fcall node, right? And at the end, we take the current, we do this thing, and here if token type is equal to dot, if token type is equal to dot at the end, like we have two options. It's either at or it's dot. There's no other option, basically. What I'm trying to say. Yeah, I really have no idea how to make it work. So find an at. The at is more like the plus, and dot is more like the multiply. But what's hard about this is that we have dot in both cases, and they have different meanings basically. Right, it's more like, yeah, more like the multiply. So as we see here, we can actually have a dot like this. So how does it look like? It's dispatch on A something, then we have a dot, another dot, then new A. No, it's like dot dot new A. I guess dispatch on A H and then the argument. So new A is the expression, this is the thing, this is the function, and this is the argument. So this is the first dispatch. So we solve this one first, and then this one, and then the full call. So it should it should be exactly the same as adding and multiplying. But I mean, this page is just like a decorator. So what if we imagine that this page is just a decorator? So while, or like the add symbol, while, or token type is dot. Like, what if we do this thing? And here say that we have either at or dot. So it's gonna be a dispatch full either way. Right? With the root as the thing, and then we advance. And if token type is equal to at, then we need to advance once. We need then to, so let's say we do the expression full, then we advance. If the current token is an at, right, if we find an at, then we advance again. We put here the class name in case like it's mandatory to have it. Then we advance, right, and we stop this. If it wasn't an at, then it should be a dot. So we don't have to advance here because this is optional. But if it exists, then we advance it here, so it's fine. Then we have a dot, right? We have a dot. So here we need to build. How about another? So this should actually be build expr simple, maybe. What if we say build expression simple? Then we have this stuff. Then this stuff, and here build expression simple. Let's think about it. Well, we want to build a no-def call because it's like easier to call it that way. Yeah, what? It's not really correct. But yeah, it's not really right that we have to call it that way. I mean, we know for sure that it's gonna be just an F call, and then we're gonna have whatever it's next. So maybe it's fine. And the idea is that we no longer need this thing with expression dot. I mean, I think this should at least parse, right? But I don't know if the order is gonna be fine. Well, it's not parsing. So on line 7, it's like this one again. What? expected dot but got identifier. So that's like for the G, right? Or at least that's how it was. Seven and 14. Yeah, it was for the G. So here we parse a simple expression, which is gonna be like the thing. Then we do a dot. We actually find a dot, so we don't have to advance. Okay, something happened. So let's go into print st and let's see. So the last print that we are gonna do is case expr dispatch full, right? So we have two cases of dispatch, case expr dispatch. We have two cases. So first one is printf, and how does it look like? It's just a dot, then the expression. So we have percentage star s dot with identify indent. Then we need to do the expression. Then we need to do the method name. Yeah. Then we need to do the type. Wait, type is first then. Type is first. Oopsie. So if type is not null, then we show it. And then for the expressions, we show the expressions. And for implicit dispatch, it should be printf, something like this. But here we say implicit dispatch, I guess. Yeah, something like that. So if we try again, I made an oopsie here. It should be just dispatch. Yeah, something like that. So we get like the implicit dispatch with f and the plus, method g, then plus. And here again I made a mistake somehow. So it's self, which is not right anyway. So it's expression. I mean, that was good. But it failed on something else. On the method value, I guess. Like, it failed here, it looks like printf. Let's put anything here, like this. Yeah, it failed on the method value. So let's go back in parser.c. But it's wrong anyway, because it's gonna be right associative, I guess. So for method value, Oh, we have this thing, but wait, what the hell is this? It should be just the if. So this is what? It's a node info. Oh, I mean, no, it should be fine. Printf simple dispatch. Yeah, it finds it. So what? And it should find it multiple times. So let's see the method names. So it is G, H, and H. I wanted to see the CL. G, H, and H. Yeah, it's good. So what does it happen? It's not copying it correctly. Current. I mean, I'm just gonna, copy it one by one or something. If it's not copying it right. Yeah, it's not copying it right. Then let's do value equals value, and value is a char pointer. But I think it's fine. So if we just copy the value like this, it's not. Wait, what? Ah, it's because here it should be dispatch. Yeah, it should have been dispatch, and yeah, it looks good now. But we need to copy the line and the thing. And for args, is it maybe the same thing? Not sure. Print is this. So we have printf %d. Let's see the number of arguments, if that works. So it's not working. Yeah, I mean, building the node like this sucks, I guess. So let's do something else. Let's go into the parser.h and let's change this to be a pointer to a dispatch, because that's the only way I can see it working. So here is gonna be a struct dispatch pointer dispatch. So just like this. So that's not gonna work, obviously. We need to allocate it. So I need to say dispatch equals, oh, but we don't have this patch, right? We don't have the structure. So let's pull this thing out into a type def. Type def dispatch node. let's go ahead and say that this should be a dispatch node. And that's something like this. Okay, fair enough. So now dispatch node, that works. We have the dispatch, and here instead of sending this thing we can say current arrow dispatch full dot dispatch, like this. But we need to send the address, right? Wait, what? Yeah, but it's gonna be an expression. And it should be okay. Yeah, so it doesn't work. So we actually need that thing. And if this thing is that current dispatch is equal to, so this is struct dispatch node, and this is struct dispatch. So here we need to dereference it. Maybe something like this, but we are gonna have some errors in print. So here we need to say dispatch.method, or like arrow, and here dispatch arrow arms. And here it's gonna be also like that. Okay, that's okay. We have the implicit dispatch for f, then we have a dot on self and this thing, but then why does it say implicit dispatch? Let's try again. So it's this. Something's wrong here. It tries to do a function call on that. What? Instead of doing a method h. So yeah, basically here we try to build the node f call. Let's just printf whatever token type we have now. So it's rbrace. It's rbrace dot rbrace. That's good because it was like dot and then the rbrace at the end. That's actually fine, but why does it say implicit dispatch there? Like, it's so weird. On the same line with boolean, and that's what? Like method? Like, how does it get to implicit dispatch? What the hell? Because there's no implicit dispatch inside of this. Weird. Oh, I didn't break. Yeah. Oh, and it's working. Oh my god. Let's diff it. Let's diff it and prove that it works. 10. With the reference, obviously. Oh no. Oh, we have some weird prints. But at the same time, we also don't have wait, what's different about it? I don't get it. I forgot to print something in this. So it's like I forgot to print the name. What? So in dispatch full we have this. Oh, I didn't print the name. Why? Method name, yeah. It's the same. It is the same, man. Yeah. Oh my god. I did it. Okay, so yeah, actually, it actually works. Oh, on all of them. We don't get the errors right because I need to figure out how to actually print the errors. But I'll do that on now because it's not interesting. And yeah, but we actually get the AST for our language. So we actually build the AST even for more complicated stuff like this with function calls. And yeah, we have the AST. This is like a function call, and this is like the expression. This is the method that we call on it, and on that result we call another function. So yeah, that's basically the AST. And I don't even want to press Shift G to see how many lines. Well, this is wow, it's huge. But yeah, like the only thing that I need to fix is the error messages because they are really trash. And yeah, but it looks like it makes the AST. So yeah, then it means that the method of and just make it work on this one with add was actually fine. Hopefully. I mean, yeah, this is what's a bit weird. Like, what did that mean? I'm not really sure because obviously add will be the first one that's applied because it's inside of the expression. But I mean, anyway, doesn't matter. We actually managed to do this and get the AST. And yeah, we also have that small test.py Python script that we did in the beginning just to show you how to get things working. I mean, yeah, I'm not gonna include it. Maybe make a gist out of it if you really need it. But yeah, I mean, we actually got the AST to work. And let's see, also the Lexer still working, obviously. But yeah, we got the AST. And what's left is for me to make this thing, the errors. And yeah, then we can actually start on doing some semantic analysis, catch some errors, and then at the end build assembly for the language, and I mean compile it to an executable and actually run it. So yeah, those are the main goals. But we'll see. So See you on the next coding.